Hi students, welcome to today's video. So today we are going to a new topic, mathematical induction. So there are many multiple choice questions that can come from the topic mathematical induction for many competitive exams. So today we will just go through 10 questions from this topic. So first, to get an idea of what is mathematical induction, I'll go to a non-multiple choice question first and then we'll go to the multiple choice questions, but I just need to explain what is the basic principle of mathematical induction. Show that for any natural number n, 3 raised to 2n minus 1 is divisible by 8. So we have to prove something. We have to prove that for any natural number n, 3 raised to 2n minus 1 is divisible by 8. So the basic principle of mathematical induction is that any statement is true for any natural number n if it satisfies two conditions. One is P of 1 should be true. Okay. So P of 1 is true. Then second thing is we assume P of k is true. If we assume P of k is true, P of k plus 1 also should be true. Then we can conclude that this P is true for any natural number n. So what are the steps? For any statement P, you have to prove that P of 1 is true. Then you have to assume P of k is true. If P of k is assumed to be true, then P of k plus 1 also should be true. So let's go to this example. P is equal to 3 raised to 2n minus 1. So first we go to P of 1. So what is P of 1? 3 raised to 2 into 1 minus 1. So P is equal to 3 raised to 2n minus 1 is divisible by 8. So that is a statement. Okay. So P is like we have to prove that 3 raised to 2n minus 1 is divisible by 8. So what is P of 1? P of 1 is equal to 3 raised to 2 into 1 minus 1, which gives you 8. So it is true because 8 is divisible by 8. So you can say that P of 1 is true. Now we are assuming that P of k is true. So P of k is true, we have to assume. So P of k is equal to 3 raised to 2k minus 1 should be divisible by 8, which means that 3 raised to 2k minus 1 is equal to 8m, where m is any natural number. A multiple of 8 is naturally divisible by 8. So we are assuming P of k is equal to true, which gives 3 raised to 2k minus 1 is equal to 8m. Now we go for P raised to P of k plus 1. So what is P of k plus 1? It will be 3 raised to 2k plus 1 minus 1, which will give you 3 raised to 2k into 3 square, isn't it? 3 raised to 2k into 3 square minus 1, which will give you 9 into 3 raised to 2k minus 1. So what is 3 raised to 2k? From this statement you will be getting 3 raised to 2k is equal to 8m plus 1. Okay, so we assume that P of k is true, so which will be giving you 3 raised to 2k minus 1 is equal to 8m. So from there you will be getting 3 raised to 2k is equal to 9 into 8m plus 1 minus 1, which will be giving you 72m plus 9 minus 1, which will be equal to 72m plus 8. So it will be actually 8 into 1 plus 9m, which will be giving you 8r, where r is equal to 1 plus 9m. So what does it mean? So when you are telling P of k plus 1 is equal to 8r, it means that P of k plus 1 is also a multiple of 8, or P of k plus 1 is also divisible by 8. So what do you get from here? P of 1 is true, of course P of 1 is equal to 8, so P of 1 is true. We assumed P of k is true, and from that we got P of k plus 1 is also true. So we can conclude that for any natural number n, 3 raised to 2n minus 1 is divisible by 8. So this is how the mathematical induction goes. Now we can go to the second question. Show that for any natural number n, 3 raised to 2n plus 2 minus 8n minus 1 is divisible by 8. So again, first we can go to P of 1. So what is P of 1? P of 1 will be 3 raised to 2 into 1 plus 2 minus 8 into 1 minus 1, which will be giving you 3 into 2 plus 2, which will be giving you 3 raised to 4. 3 square is equal to 9. So 3 raised to 4 is equal to 81. So 81 minus 8 minus 1. which will be giving you 81 minus 9 is equal to 72, which is a multiple of 8. Or 72 is divisible by 8, which means P of 1 is true. So we got P of 1 is true. Now we are assuming P of k is equal to true. So what you will be getting? 3 raised to 2k plus 2 minus 8k minus 1 is equal to 8m. It is a multiple of 8, or it is divisible by 8, which means 3 raised to 2k plus 2 minus 8k minus 1 is equal to 8m, where m is any natural number. So we are assuming this. Now we go to p raised to k plus 1. We have to prove p raised to k plus 1 is also true. So what you will be getting? P raised to k plus 1 is equal to 3 into 2 raised to k plus 1 plus 2 minus 8 into k plus 1 minus 1. So what you will be getting? So you can get like 3 raised to 2k plus 2 into 3 square minus 8k minus 8 minus 1. Okay, so it will be like 9 into 3 raised to 2k plus 2 minus 8k minus 9. So what is this 3 raised to 2k plus 2? So from here you will be getting 3 raised to 2k plus 2 is equal to 8m plus 8k plus 1. So you will be getting like p raised to k plus 1 is equal to 9 into 8m plus 8k plus 1 minus 8k minus 9. So totally you will be getting like 72m plus 72k plus 9 minus 8k minus 9. So you will be getting like 72m. So you will be getting 72m minus 64k. Okay, this 9 and 9 will be cancelled. So 72k minus 8k is equal to 64k. So 72m minus 64k, which gives you 8 into 9m minus 8k, or it will be 8r. We are just substituting 9m minus 8k is equal to r. So p of k plus 1 is equal to 8r, which shows that p of k plus 1 is also a multiple of r, or p of k plus 1 is also divisible by 8. So you proved like p of 1 is true and p of k is true. You assumed p of k is true, and from there you got p of k plus 1 is also true. So you can conclude that for any natural number n, 3 raised to 2n plus 2 minus 8n minus 1 is divisible by 8. Now we are going to the multiple choice questions. The product of 3 consecutive natural numbers is divisible by. So for any statement, first you have to check for p of 1. So most of the multiple choice questions, you will be getting the answer by just doing p of 1. So that is the point you have to remember. That's the inference you got from the principle of mathematical induction. Here there are no options like none of these, or such options are not there. So just by doing p of 1, you may be getting the answer. So let's try. What is the question here? The product of 3 consecutive natural numbers. So let's write 3 consecutive natural numbers first. n plus 1 and n plus 2. n into n plus 1 into n plus 2. It will be divisible by which number? That is a question. So let's do p of 1. P of 1 is equal to 1 into 1 plus 1 into 1 plus 2, which will be giving you 1 into 2 into 3 equal to 6. And 6 is there in the choices, and there is no other choice like none of these. So you can straight away go to the answer. Your answer is 6. So you just need to do p of 1 only. First you have to write the question in the format 3 consecutive natural numbers. So it will be n into n plus 1 into n plus 2. Then find out p of 1. So you will be getting 6. Next question. 2 raised to 3n minus 1 is divisible by. So here you are having none of these options. So you have to be very careful. You have to prove the principle of mathematical induction. Then only you will be getting the correct answer. Sometimes it might be none of these. So you have to go through all the 2 steps. So first p of 1. What is p of 1? P of 1 will be 2 into 3 raised to n, which will be giving you 2 raised to 3 into 1 minus 1. So it will be 2 cube minus 1 is equal to 7. So p of 1 is divisible by 7. So you are assuming that p of k is equal to a multiple of 7, or p of k is equal to 7m. You are assuming p of k is true. Why are we going through this step? Because there is an option none of these. You cannot just give the answer as 7 because none of these option is there. So only if P of k plus 1 is also true, you can conclude that 7 is the correct answer. For our previous question, there was none of these option. So you can straight away go to the answer. But here, there is a none of these option. So you have to go to the second step also. So what is P of k plus 1? So P of k plus 1 is equal to 2 raised to 3 into k plus 1 minus 1, which will be giving you 2 raised to 3k into 8 minus 1. So what you will be getting finally? So 2 raised to 3k, what is 2 raised to 3k? 2 raised to 3k is 7m plus 1. So 8 into 7m plus 1 minus 1, which will be giving you 56m plus 8 minus 1 or 56m plus 7. So you will be getting 7 into 8m plus 1 or 7r, where r is equal to 8m plus 1. So P of k plus 1 is equal to 7r, which implies that P of k plus 1 is also a multiple of 7. So P of 1 is true, we assumed P of k is true, and we got P of k plus 1 is true. So what is our final answer? Our final answer will be 7. 2 raised to 3n minus 1 is divisible by 7. Now our next question. 10 raised to 2n minus 1 plus 1 for every n belonging to n is divisible by 10 raised to 2n minus 1 plus 1. So we go to P of 1 directly. So P of 1 is equal to 10 raised to 2 into 1 minus 1 plus 1, which will be giving you 10 raised to 1 plus 1, which is equal to 11. So these questions are very simple. If you know the principle of mathematical induction, you can straight away get the answers within seconds. But otherwise, you will be confused how to do these kind of questions. So that is why I am doing this video. So 10 raised to 2n minus 1 plus 1, there is no option of none of these. There is no option of none of these. So you can directly go to the answer 11. Next question. If n is an odd positive integer, then a raised to n plus b raised to n is divisible by. First option a square plus b square. Second option a plus b, third option a minus b, and fourth option is none of these. So what is P of 1? P of 1 is equal to a raised to 1 plus b raised to 1, which gives you a plus b. So it is divisible by a plus b. But you cannot write here a plus b straight away because there is an option none of these. Now what is the next step? Here it is written n is an odd positive integer. So n is an odd positive integer means now you can go to the next step also, P of 3. So P of 3, what you will be getting? Here you cannot assume like k and k plus 1, it will be very confusing because here it is specifically given that n is an odd positive integer. So you can go to the next odd positive integer, which is P of 3. So P of 3 will be equal to a cube plus b cube, which is equal to a plus b into a square minus ab plus b square. So here also a plus b is coming. So you can conclude even P of 1 also you got it is divisible by a plus b, and P of 3 also you got it is divisible by a plus b. So you can conclude that here a raised to n plus b raised to n is divisible by a plus b. Now next question. N square plus n is dash for all n belonging to n. So n square plus n. So here also here even, odd, either even or odd, and none of these. So these are the options. So none of these options is there. So you have to go through both the steps. So P of 1 is equal to 1 square plus 1, which is 2, and it is even. So now you are assuming that P of k is also even. Okay, so P of k is equal to 2r. You are assuming P of k is even. That means k square plus k is equal to 2r. Now we can go to P of k plus 1. What you will be getting? P of k plus 1. P of k plus 1 is equal to k plus 1 the whole square plus k plus 1. So what you will be getting? K square plus 2k plus 1 plus k plus 1, which will be giving you, what is this? K square plus k, k square plus k, k square plus k is equal to 2r. So you will be getting 2r plus 2k plus 2. So here 2k is there, and here 1 plus 1 is equal to 2, which will be giving you 2 into r plus k plus 2, or is equal to 2m, which shows that P of k plus 1 is also even. So P of 1 is even, you assumed P of k is even, and you got P of k plus 1 is also even. So your final answer will be n square plus n is even for all n belonging to n. Here you checked all these steps because there is an option none of these. So you are assuming and you are checking and you got the answer. So n square plus n is even for all n belonging to n. 8th question. 2 into 7 raised to n plus 3 into 5 raised to n minus 5 is divisible by dash for all capital N belonging to natural numbers. So when you are seeing this question for the first time without any practice or without any idea of mathematical induction, you will be very confused. Okay, so if you know this principle, it is very easy. You just have to check out P of 1 here, because there is no option none of this. So P of 1 you will be getting as 2 into 7 raised to 1 plus 3 into 5 raised to 1 minus 5, which will be giving you 14 plus 15 minus 5, or 14 plus 10 is equal to 24. So indeed we are having the option 24 here. So 24 will be your answer. Now ninth question. If n belongs to n, then 7 raised to 2n plus 2 raised to 3n minus 3 into 3 raised to n minus 1 is always divisible by. Again you are having an option none of these here. So you have to go through both the steps. So what is the question here? P is equal to 7 raised to 2n plus 2 raised to 3n minus 3 into 3 raised to n minus 1. So what is P of 1? P of 1 will be 7 raised to 2 plus 2 into 3 minus 3, which will be giving you 0, into 3 raised to 1 minus 1, which will be equal to 3 raised to 0. So 7 square plus 2 raised to 0 into 3 raised to 0, or 7 square plus 1 is equal to 50. So P of 1 is equal to 50, or P of 1 is divisible by 25. 25 is there in the option, so P of 1 is divisible by 25. But you cannot write the answer straight away. You have to assume P of k is equal to 25m, which will be giving you 7 raised to 2k plus 2 raised to 3k minus 3 into 3 raised to k minus 1 is equal to 25m. So what is P of k plus 1? P of k plus 1 is equal to 7 raised to 2 into k plus 1 plus 2 into 3 into k plus 1 minus 3 into 3 into k plus 1 minus 1. Okay, so what you will be getting? You will be getting like 49 into 7 raised to 2k. Okay, 7 raised to 2k into 7 square, which will be giving you 49 into 7 raised to 2k plus, you are just trying to get this format. Okay, you are trying to get this format. So it will be 2 into 3k minus 2 raised to 3k minus 3 into 8. Okay, so here you will be getting 2 raised to 3k, and here minus 3. So minus 3 you are writing it together into 2 cube. So 2 raised to 3k minus 3 into 8 multiplied by 3 raised to k minus 1 into 3. So here you will be getting, here you are having 3 raised to k minus 1. Okay, that is the reason why we are going so. Okay, so what you will be getting finally? It will be equal to 49 into 7 raised to 2k plus 8 into 3 is 24. So 24 into 2 raised to k minus 2 raised to 3k minus 3 into 3 raised to k minus 1. Okay, these two terms we are writing. These two terms, 8 into 3 is equal to 24. You have to do with me, then only you will be getting all these steps, otherwise there will be confusion. So you please do with me also. So it will be 49 into 7 raised to 2k plus 24 into, so what is 2 raised to k minus 3 into 3 raised to k minus 1? So what is this? From this step, what you will be getting? 25m minus 7 raised to 2k. So 25m minus 7 raised to 2k, which will be giving you 49 into 7 raised to 2k minus 24 into 7 raised to 2k, which will be giving you 25 into 7 raised to 2k plus 24 into 25m. Okay, you understood? Here you are having 49 into 7 raised to 2k. You are multiplying 24 inside. So you will be getting minus 24 into 7 raised to 2k. So 49 into 7 raised to 2k minus 24 into 7 raised to 2k, which will be giving you 25 into 7 raised to 2k plus 24 into 25m. So which will be giving you 25 you are taking outside. So 7 raised to 2k plus 24m, which will be giving you 25r, where r is equal to 7 raised to 2k plus 24m. So what did you do here? Just now you proved P of 1 is a multiple of 25. You assumed P of k is equal to 25m, and from there you got P of k plus 1 is equal to 25r, or P of k plus 1 is also divisible by 25. So P of 1 is true, you assumed P of k is true, and you got P of k plus 1 is also true. So what do you conclude from this? If n is belonging to n, then 7 raised to 2n plus 2 raised to 3n minus 3 into 3 raised to n minus 1 is always divisible by 25. You need to do the second step because there is an option of none of these. Suppose we assumed P of k is true and we got P of k plus 1 is not true, means none of these will be the answer. So there is an option of none of these, so you have to do both the steps and verify and be sure before you answer. Next, the last question of the video. Let P be the statement n square minus n plus 41 is prime. Then which of the following is not true? So what you can do, you can actually do all these options and see. For fast, if you are able to do, you can all these options and see. So what is P of 2? P of 2 will be equal to 2 square minus 2 plus 41. So 4 minus 2 is 2, 2 plus 41 is equal to 43, which is a prime number. Then P of 3 will be equal to 3 square minus 3 plus 41, which will be giving you 9 minus 3 is equal to 6, and 6 plus 41 is equal to 47, which is also true. And what is P of 5 will be equal to 5 square minus 5 plus 41, which will be 25 minus 5 is equal to 20 plus 41 is equal to 61, which is again prime. And P of 41 is equal to 41 square minus 41 plus 41, which will be giving you 41 and 41 get cancelled, which is 41 square, and 41 square is not prime, so our answer will be P of 41. Or just by thinking, you can say n square minus n. When n square minus n is equal to 41, you will be getting like, or if somehow this 41 is getting cancelled, you will be getting n square. N square is not prime, so here n should be 41. When n is 41, minus 41 and plus 41 will be getting cancelled, and therefore you will be getting only n square, and which is obviously not prime, so P of 41 is our answer. So just by viewing it also you can do. I just did the steps, and when you are getting a lot of practice, these kind of questions you can think. When you see the question, you can think how to proceed. Should I do only P of 1, or should I do P of 1 and assume P of k is true and verify whether P of k plus 1 is also true and then go to the answer, or just by viewing the question and just by thinking can you get the answer. So this is how you have to go for these kind of questions. It's a very interesting premise, so I'll come again with more set of interesting questions, and thank you for watching the video, and do subscribe our channel.